All right, we're going to be talking about some complex number operations. And some of you have seen complex numbers in Algebra 2. Others of you, it might have gotten skipped over due to remote learning or CP Algebra 2 or coming from another school. But complex numbers are when you need to be able to take the square root of a negative number and you can't. So instead of it being no solution, you use complex numbers to represent your solution. And so we're going to treat I kind of like we treat X, like a variable. I is actually a number, the square root of -1. We're going to talk about that down here. But right now, just think of it as a variable. Another thing that is kind of important is when you combine like terms with I, you're just going to be combining the coefficients, just like if you had 2x plus 4x and you got 6x. So this first part at the top is just adding and subtracting complex numbers. Standard form is you always put your constant term first and your imaginary term second when you write your final answer. So here's one imaginary number, 4 plus I. Here's another imaginary number, 2 minus 3I. So you're allowed to take the two constant terms and add them together to get 6. Then you're allowed to take the two imaginary terms and add them together. And if you had 1I and negative 3I, you would have negative 2I left. And this is A and this is BI. So that's your final answer and it's in the correct order. What if you have three imaginary numbers? Well, or complex numbers. You just add together your constants. So let's see, I have a 7 and a 2. So 7 plus 2 is 9. And I have a 3I, a 4I, and a negative 7I. This is positive 7I. This is negative 7I. So actually, that adds up to 0, and I just have the real number 9. So I added complex numbers together, and I ended up with a real solution. When you have a negative sign in front of a complex number, don't forget you need to use the distributive property. So I'm just going to rewrite this without parentheses. I would have 4 minus 8I, and then I have a negative 6, so that's plus 6, and I have a negative 10I. So now I can combine my like terms. I have 4 plus 6 is positive 10, and I have negative 8I minus 10I would be negative 18I as my final answer. Let's see, number 4, I would end up with 7 plus 20 is 27, and 5I minus 2I would be plus 3I. That minus sign again, I need to remember to distribute the minus sign. So 6 minus 3I minus 2 minus 4I. If I have a 6 and a negative 2, I have 4 as my real number. Negative 3I minus 4I is negative 7I. And I have three imaginary numbers here, so I'm going to distribute that negative sign. 8 minus 4I minus 4 minus I plus 2 and plus 3I. So altogether I have an 8, a negative 4, and a positive 2. So that looks like a total of positive 6. And then I have a negative 4I, negative 5I, plus 3 would be negative 2I. So practicing just combining like terms and writing them in standard form is one operation with complex numbers. Another operation is multiplication. And so we are going to review or remember that if I take I squared, I actually get back to the real number world, -1. So whenever you see an I squared term, that's just the real number, -1. The two square roots end up canceling each other out. So we call the I squared just -1. So when we do some FOIL down here, we're going to end up with I squareds. I squareds do not belong in standard form. So remember when you FOIL, you do first, outer, inner, last. So 4 times 2 is 8. Let's see, my outer would be negative 12I. My inner is plus 2i, and my last would be negative 3i squared. So these two inner terms are like terms, and that would add up to negative 10i, but these are actually both constant terms. If I squared is the same as negative 1, negative 3 times negative 1 is actually the real number, positive 3. So I have 8 plus 3 is 11, and I'm subtracting 10i. So I still want to leave it in standard form. In number 8, you're going to distribute the 3i inside the parenthesis. So 21i plus 12i squared. And we know that I squared is the same as multiplying by negative 1. So this is really negative 12, which is a constant, and then plus 21i. In number 9, maybe we'll do FOIL together one more time, and then I might have you practice pausing the video and trying 10, 11, and 12 and just checking it with the video in a moment. So let's see, negative 24 plus 40i plus 48i minus 80i squared. And negative 80i squared is actually positive 80 because it's negative 80 times negative 1. So I have positive 80. I'm subtracting 24. So 80 minus 24 is a total of 56. And I'm adding 88i. So now pause the video, and I'm going to work out the answers while you try them. So pause the video. All right, so now you're going to be checking your answers. So let's see, 7 times 20 is 140 minus 14i plus 100i minus 10i squared is the same as positive 10. So 150, what would that be, plus 86i? This one, 12 plus 24i minus 6i minus 12i squared is the same as positive 12. So I'd have 24 plus 18i. And the last one, the distributive property, 16i plus 24i squared is really negative 24 plus 16i. So there's one more operation that we're going to talk about, and that is division of complex numbers. So the rule for division is kind of the same as rationalizing the denominator. So instead of having a radical in the denominator, we do not want to have an imaginary number in the denominator. So the strategy up here at the top for all of these problems is just to multiply the fraction by 1 and to multiply by the fraction by I divided by I. Because if you multiply anything times a fraction that's the same number over itself, it's like taking whatever you started with and multiplying by 1. So you're not changing the value of what you started with. In the denominator, you're going to get 3i squared, which is just negative 3. So you've eliminated I from the denominator, which was your goal. In the numerator, you're going to end up with, let's see, 4i when you distribute minus 7i squared. So that's not written in standard form because negative 7i squared is really positive 7 plus 4i divided by negative 3. I'm fine with you stopping at that fraction. On the SAT or multiple choice type test, they may write their answer as negative 7/3 because that's their A, minus 4/3 I. So they're just taking the two parts of the fraction and splitting it up into two separate fractions. Either of them is the correct answer. So if I multiply the next one by I over I, let's see, I get 2i plus 4i squared over 5i squared. 4i squared is the same as negative 4 plus 2i over negative 5 because I squared is negative 1. So 5I squared is negative 5. Oops, can't see that. You could also write your answer as positive 4/5 minus 2/5 I, because this is a negative divided by a negative, so that first term comes out positive. Number 15, multiply by I over I. So the numerator, you'd get 2I minus I squared over 2I squared. So let's simplify that. Negative I squared is negative negative 1, so that's positive 1, plus 2I all over negative 2, or negative 1/2. 2 divided by negative 2 is just negative 1. So negative 1/2 minus 1I, or just minus I. The last one, if I multiply by I over I get 10I plus 5I squared over I squared. So negative 5 plus 10I over negative 1. And you don't really have to leave it over negative 1. You could just divide each term by negative 1. So 5 minus 10I. So the last two problems I'm going to show you how to do actually have a binomial in the denominator. And so there's a different strategy that you need, because if you just multiply by I, you're going to still distribute and have an I term left, right? You'd have negative 2I squared, but you'd have 1I left, or you'd have 2I left. So the idea is multiplying by the conjugate. And so a conjugate is just the opposite signed term. So in the first example, if the denominator is 1 minus 2I, you're going to use 1 plus 2I, both in the numerator and the denominator, because you have to multiply by the same number over itself so that you're multiplying by 1 and you're not changing the value of the problem. So you're actually going to have to do FOIL twice. So when I do FOIL in the numerator, 3 times 1 is 3. I would get 6I plus 7I, so plus 13I, and then plus 14I squared is really negative 14. So my numerator is negative 11 plus 13I. In the denominator, because you're multiplying by a conjugate, your outer plus your inner term adds up to 0. So you really just get 1 times 1 is 1, and negative 2I times positive 2I is negative 4I squared, which is really just the number positive 4. 1 plus 4 is 5. So because you're multiplying by conjugates, your outer and your inner terms, your I terms, add up to 0, and you end up with just a constant term left. So you should pause the video and try number 18 on your own. And now I'm going to show you how to do number 18. If the denominator is 2 plus 4I, you want to multiply by the conjugate of that, 2 minus 4I on top and bottom. 8 times 2 is 16. For the outer, I would get negative 32I. For the inner, I would get plus 12I. And for the last, I would get negative 24I squared, which is really positive 24. Combining like terms would give me 40 minus 20I. In the denominator, I only have to do the first terms and the last terms because outer plus inner always add up to 0. 2 times 2 is 4. 4I times negative 4I is negative 16I squared, which is positive 16. So I'm really dividing by 20. You could reduce this and just say it's 2 minus I, because 40 divided by 20 is 2, and negative 20 divided by 20 is 1. So it simplifies to 2 minus I. So you are completing the guided practice 1 through 4 and submitting your answer through Google Classroom.